Hey, physics peeps. We're going to do some review for the vectors and projectiles test, and I'm going to try to go through some of these things pretty quick, but also give an overview of just what you need to know for the test, how to set things up, and as we go through problems, I encourage you to do the problems with me, whether that means like stop the video and do the problem along with me, but or if that means kind of do it on your own, that's fine too. As review, this unit is a lot about doing rather than just looking and knowing it. And so you got to be able to do it on paper. So do the problems. So here we go. When we talk about vectors, projectiles, and things like that, there's some useful equations that we use, especially when we deal with triangles. You'll see that pop up here in just a minute. But we use two things. Pythagorean's theorem, this a squared plus b squared equals c squared, and the SOHCAHTOA stuff. You might have seen that stuff before, but we're going to avoid this whole tangent thing. You'll see why. But terms that you need to know: components, distance, displacement. When you talk about components, if we take a hiking path or hike around a lake or something like that, the components are really, each time that we change directions, we're adding a component to our path. And that's what it is. Distance is really how far that we traveled. So if we actually measured how far we traveled during this path, that's our distance. Displacement, though, is really how far we got from point A to point B, or from start to finish. And it's just this distance, how far between those 2 points. Even though we traveled this distance, the displacement is only going between those 2 points. That's it. And hence, when you're solving all problems, distance, just add up your components. Displacement, you got to use Pythagorean's theorem, that a squared plus b squared equals c squared. And then when you use solve out for x and y components, you use SOHCAHTOA. Cosine solves for x, sine solves for y. You'll see that in here in a bit. And so here's problems that you'll end up seeing on the test. Determine the distance in each case, determine the displacement. So when we need to determine distance, again, it's just like if these represented how far someone hiked or walked or something like that. They walked 4 meters this way, 3 meters this way. The distance is really just adding those things together. When someone drove 15 kilometers this way, 90 kilometers this way, the distance is just adding them together. This one, you add them together, you get 1 mile. And displacement, though, is different. When you want to find displacement, it's how far from point A to point B, not this distance, but how far here to here. So this is where you have to use a squared plus b squared equals c squared. So you see displacement, use this equation. But you can just label each one of these as either A or B. The big thing is that you are solving out for C, and side C is this long side. And so you put in like 3 for A, you got to square it. 4 for B, you got to square it. And so you get 9, 16, you add together, you get 25. But we're not solving out for c squared, we're solving out for c. So you have to take the square root at the end. So square root of 25 and get 5. And you do that the same way for each one of these. It's kind of the same process. So you'll run into some other problems like sketch x and y components. X and y components are really just like x and y parts of graphs. X-axis, it's horizontal. Y-axis is vertical. And so you'll have a horizontal piece and a vertical piece that come together, and you end up making a triangle. So x has to be horizontal, y has to be vertical. The angle they give you is really kind of this angle that's in here, and this is an angle mark, not a number 1. And then we'll talk about this one here later. Or you can just kind of forget about it for now. When you solve out for the x and y components, the big thing is that cosine solves for x, sine solves for y. But if you need to set it up and solve for them, you really set them up the same way each time. So it's always sine of the angle or cosine of the angle they give you. And that's the same thing in each one of these cases. So that part is you'd have to do 1 where it's sine 30 degrees, cosine 30 degrees. And so you'll have to do those 2 parts. On the other side of the equation is like equals sine, it has to be y up on top. Cosine has to be x up on top. Okay? And then what goes on the bottom is this displacement or the resultant or the value they give you for this long line that it's representing. So we have sine 30 degrees equals y over 12 newtons. Cosine 30 degrees equals x over 12 newtons. You solve out for this y, you solve out for the x by putting this into your calculator and multiplying it by whatever's on the bottom. Put this in your calculator, multiply by whatever's on the bottom, and it'll give you the answer. But you need to know which one's x and y. Same thing's done over on this side. And projectiles, we'll go in a little more in depth with this stuff. But when we talk about projectiles, you need to know terms, and you need to also be able to follow through on problems. We'll talk about that here in a second. So some terms you need to know. Projectile, any object moving through the air, but gravity is the only force acting on it. We'll forget about air resistance. Trajectory is the path that a projectile follows, whether it's dropped straight down, whether it's thrown up in the air at an angle, or anything like that. But that's its trajectory. The shape that it makes is called a parabola. You need to know that. And then range is just a horizontal distance. Here, the range is 0 because it doesn't move any horizontal distance. Range here is only from here to here along the ground. So this horizontal distance is measured along the ground from where it started to where it ends up landing. And that's kind of it. And other things you need to know about projectiles is that if something's projectile is shot at an angle, 45 degrees will give you the longest range. And then if you have two angles that hit the same range, those two angles actually add up to 90 degrees. So like if you knew that something was shot at 60 degrees and you needed to figure out another angle that will hit the same range that it did, and well, it's really 30 because 60 and 30 add up to 90. If something was launched at 80 degrees, another angle that will hit the same range is 10. Or if it's 13 degrees, the other angle that hits the same range is 77 because they add up to 90. That's kind of it. Now getting into the tough projectile problems, this is a process and it's really done the same way each time. If you can go through these problems and do it the same way every time, you're just putting in different numbers and calculating different numbers, then you'll be good. But this is where you got to be able to do it. So some hints. Make sure that you split up your problems, x and y. List your initial speeds on both sides. Solve for time on the y side. Use that time to solve for the range and the vertical velocity. Horizontal velocity is the same as what's given at the beginning of the problem. And this is just kind of like some things you'll end up seeing how it's done. So we're going to work through one problem here, and then I'll kind of let you work through the other one. I'll have the work on the PowerPoint or the file that goes along with this. But we're going to solve this one out. A cannonball is fired horizontally to the right off a cliff at a speed of 90 meters per second. The cliff is 1 meter high. Determine each of these things: range, horizontal speed, vertical speed. So when we talk about splitting up x and y, even though the projectile follows this trajectory and the parabolic shape, really we imagine that if it does two different things, we split it up into x and y components. So x on one side, y on the other, and this is what you show in your work. And the x path, we really kind of think of it following this path, the horizontal path. And like as if gravity doesn't pull it down, it'll end up kind of just following this path along, going in a straight line. And its initial speed is 90 meters per second because this was launched horizontally at 90 meters per second. So in our work, we just show this. Split up x and y. Initial speed on the x side is 90 meters per second. There's kind of like a little division between the x and the y. We got to keep them separate. And we will also list an initial speed on the y side. On the y side, we actually imagine it following this path, like if it was dropped straight down. But because it was launched horizontally, not up or down at an angle, its initial speed vertically starts at 0. And in each case, horizontally, if we imagine this actually going in a straight line, we know that it would be going at a constant speed. And this one, as it falls down vertically, will be accelerating because of gravity. And that's kind of the gist in how you start off the problem. The other things that you'll need 3 equations, and these will be given to you on the test or on your reference sheet. So the 3 equations you use are these: v equals d over t, d equals vi times t plus 1/2 at squared, and vf equals vi plus a times t. So those 3 equations are on your reference sheet. They are in this order, and you will be using them in this order as you solve out the problem, which just makes it kind of nice. So we're going to start off by solving out for the range. Range, it's a horizontal distance, which means that you solve it on the horizontal side, the x side. And because this is moving at constant speed, it's not accelerating. You have to use an equation that has no acceleration in it. Keep it. Go from current side. There we go. Okay. So we're going to use this equation, v equals d over t. And we're going to solve out for the range, this horizontal distance, which means we need to know the other stuff. The speed, it's 90 meters per second, equals the distance, we'll solve for it, and the time. The time we don't actually know. They don't tell us in the problem. If we don't know it on one side of the problem, we can actually go to the other side to solve for it. And that's where we're going to use this other, or the second equation. So we're going to write this out. Equals 1/2 at, or vi times t, sorry, plus 1/2 at squared. So when we put stuff into this equation, it has to relate to y values or stuff that's on our y side. So like the distance is actually given to us. It's a vertical distance. The cliff is 1 meter high. So we can put that 1 meter in for our distance here. We can't put it over here. This is a horizontal distance. This is a vertical distance. But because it's falling 1 meter, it's actually -1. Equals the initial speed. On our y side, the initial speed is 0 times t, but anything 0 times t, 0 times anything, it doesn't just equal 0. So we don't have to worry about this part. Plus 1/2 times acceleration. The acceleration, it's from gravity, so it's pulled down at -9.8 meters per second squared times t squared. And we're going to solve for the time. And so now we go through and we simplify things to solve for that t. We have -1 on this side. We have 1/2 times -9.8. If I put that on my calculator, I get -4.9 times t squared. And then to get rid of the -4.9, I have to divide it, not add it. I have to divide by -4.9 on both sides. And if I divide that, now I gotta check this on my calculator. This I can't do it in my head. 1 divided by -4.9. I get 0.204 is equal to t squared. But I'm not done. I need t, not t squared, so I have to take the square root of both sides. If I do that, I get 0.452 seconds for that time. Now that I have that time, I can take that time, plug it in over here, 0.452, and solve for the distance by multiplying these things together. If I do that, I'll end up with this distance equals 40.66 meters. That is my range, 40.66 meters. My horizontal speed is 90 meters per second, because that's what they told me to at the beginning. My vertical speed, it comes from this third